You wire up the API, the payloads are returning flawlessly, you map the JSON to the DOM, and you finally render the text on the screen.
Right. The big moment.
Yeah, exactly. But immediately it feels hostile to the human eye. Like, it doesn't look like a polished application at all.
No, it looked like a raw data dump from like a 1998 terminal.
Yes. The data is all there, it's structurally perfect, but actually sitting down and reading the paragraphs you just rendered feels like a total chore for you.
Yeah, it's a very specific kind of friction, because the compiler reads it perfectly. The browser parses the HTML without throwing a single error.
Sure.
But the biological system on the other side of the screen, your human visual cortex, it's expending massive amounts of subconscious energy just trying to track the words.
And that is the exact frustration we are tearing apart today. Welcome to the deep dive. We're diving straight into Chapter 5 of Web Design for Backend engineers.
We're getting right into the mechanics today.
Completely. We are looking directly at the microscopic CSS-level mechanical details that determine whether text is actually readable or whether it just causes you eye strain.
Yeah, we aren't looking at high-level structural decisions today. No font choices or layout grids.
Right, we're focusing purely on the physiological mechanics of reading on a screen. Okay, let's unpack this, because these small CSS values really are the difference between an interface feeling amateurish and feeling professionally engineered.
Definitely. And the biggest trap engineers fall into when rendering text to a UI is just blindly trusting the browser defaults.
Oh, for sure.
There's this assumption that, Chrome or Firefox is engineered by brilliant developers, so the default CSS values they apply to a simple paragraph tag must be, ergonomically optimized for human reading.
But they aren't.
They really aren't. They are mathematical defaults. They're largely inherited from legacy specifications, not biological ones.
Right. So let's start with the most offensive default of all, which is the vertical space separating lines of text. The CSS property is line height.
Yes, or leading, if you want the old metal typesetting term.
Right. If I just throw a block of text into a browser without styling it, the default line height is usually around 1.2, meaning the space between the baselines of the text is 1.2 times the font size.
Which sounds reasonable.
Yeah, I've always assumed that was a solid logical ratio. I mean, why is the default essentially wrong for modern web readability?
Well, mathematically it feels logical, but biologically it's a disaster for standard body text. To understand why 1.2 is so punishing, we really have to look at how human eyes actually process information.
Okay.
When we read, our eyes do not glide smoothly across a line of text like a scanner. They make rapid, microscopic jumps called saccades. We fixate on a cluster of words, jump, fixate, jump.
Oh, so it's more of a stutter step than a continuous pan across the screen.
Exactly. But what's fascinating here is that the most dangerous moment in reading happens when you reach the end of the line on the right side of the screen.
Because you have to go back to the beginning.
Right. Your eye have to perform what's called a return sweep. The eye muscles physically snap your vision back to the left margin and simultaneously drop down exactly one horizontal line.
I feel like I know where this is going. If the line height is only 1.2, those horizontal lines are packed incredibly tight.
They are too tight for the mechanical precision of the eye. The visual landing pad for that return sweep is simply too narrow.
So you miss.
Yeah, at a 1.2 line height, your eye frequently overshoots or undershoots. You accidentally jump down 2 lines, or you reread the line you just finished.
Which is so frustrating.
And even if you don't consciously notice it happening, your brain is actively burning cognitive energy, just steering your eye muscles to hit the right target.
That makes so much sense. It feels exactly like opening a massive block of unformatted code with 0 empty lines separating the logical chunks.
Oh, that's a great way to put it.
Yeah, like everything is just vertically stacked. My code editor handles it fine, but as a human trying to parse it, I lose my place instantly. I literally have to physically trace the screen with my cursor to figure out which nested bracket I'm looking at.
Yes, it's exact.
It's technically functional, but it's mentally exhausting to parse.
That is the perfect analogy. And the mechanical fix in CSS for a web interface is incredibly straightforward. For standard body paragraphs, you have to force that line height up to 1.5 or even 1.6.
So just brute force it wider.
Exactly. By pushing the value to 1.5, you drastically increase in the vertical breathing room. You are giving the human eye a massive, unmissable landing pad for every single return sweep.
Okay, so 1.5 or 1.6 is the baseline for body paragraphs.
Yeah.
But wait, if I apply a global rule setting every single text element to 1.6, what happens to the massive text, like a giant H1 page title?
It breaks.
Right, because if I have a title that wraps to 2 lines and I apply a 1.6 line height to an 80 pixel font, the gap between those 2 lines is going to be enormous.
Yeah, it will look completely broken. It will look like two entirely disconnected elements just floating away from each other, and that is the critical exception to the rule. Headings require the exact opposite treatment. They need to be tightened.
But why? Like, why does the physiology change just because the text is bigger?
Well, because of the length and the frequency of the return sweep. A heading is typically only 1 or 2 lines long.
Right.
You aren't forcing the user to make that treacherous return journey over and over again. Furthermore, the letters themselves are physically massive, which means the baseline is massive. A line height of 1.1 or 1.2 is plenty of space for the eye to track.
So you can afford to tighten it up.
Exactly. Tightening headings down to 1.1 or 1.2 makes them feel cohesive, like a single punchy thought, rather than a scattered list of random words.
Okay, so it's all about minimizing the friction of that return sweep, which logically brings us to the horizontal axis.
Right, because line height doesn't exist in a vacuum.
Yeah, because if the vertical landing pad is important, the actual distance the eye has to travel across the screen must be a massive factor. If I'm reading a line of text that stretches all the way across a 34-inch ultra-wide monitor, that return sweep is like a marathon.
It is, and it's a marathon the eye usually fails. There's a direct causal relationship between line height and line length. The longer your line of text, the more generous your line height needs to be.
Yeah.
But the CSS property we really are looking at here is max width.
Okay.
Typographers and cognitive researchers have studied this extensively, and they've found a very strict physiological limit. For comfortable reading, a single line of body text should contain roughly between 45 and 75 characters.
Wow, that is a very specific window. What happens if I constrain a text column to something super narrow, below 45, like 30 characters?
It becomes incredibly choppy. The eye is forced to trigger that return sweep every 2 or 3 words. It feels like reading a grocery receipt.
Oh, yeah, I hate that.
You can never build up a rhythm or absorb a complete thought before you are forced to jump back to the left margin again.
And if we let the text fluidly expand past that 75-character limit, say we hit 150 characters wide on a big monitor.
The horizontal distance becomes so vast that the eye loses its tracking completely. When you reach character 150 on the far right and your eye attempts to snap all the way back to the left margin, the angle is just too shallow. You almost always lose your place.
So text should literally never stretch to fill a wide monitor.
Never. This implies a very strict rule for UI development.
You know, here's where it gets really interesting for an engineer, because this physiological limit is completely identical to a standard code linter limit.
Oh, that's a great point.
Yeah, think about any standard backend repository you work in. We run tools like prettier or standard language linters that violently reject any code line that exceeds 80 characters or maybe 100 characters.
Yep, the build fails.
Literally, if I write a wildly nested function that pushes a line to 150 characters, the CI/CD pipeline fails my pull request.
And why do the maintainers enforce that?
Because wide code is unreadable code. Even if I have a giant monitor, scrolling horizontally or tracking a massive string across my entire field of vision causes me to miss syntax errors. The linter forces a line break purely for my cognitive protection as a developer.
Exactly. You are already enforcing horizontal constraints for your compiler and your fellow engineers. You just need to apply that exact same mechanical constraint to the prose on your web page. You wouldn't write a 200-character wide code file just because your monitor is huge.
Right. And you shouldn't do it with text either. So how do we translate that 75-character limit into CSS? I mean, I can't really tell CSS to count the characters and break the box.
No, you don't need to count characters. You just set a structural boundary. A CSS max width of roughly 650 to 700 pixels perfectly translates to about 65 to 70 characters at a standard 16-pixel body font size.
Oh, that's easy.
Yeah, that single line of CSS max width. 700 px creates an invisible fence.
And that explains why reading documentation on a modern, well-engineered site feels so much better than reading a legacy forum. You open a great documentation page on a massive monitor, and there is just a single narrow column of text dead in the center.
With massive oceans of empty space on the left and right.
Yes. I used to look at that and think it was wasted real estate. Like, why not put a sidebar there or just let the text expand?
Well, if we connect this to the bigger picture, it is not wasted space at all. It is a protective buffer. That white space is actively working to hold that 700 pixel boundary in place, ensuring your eyes never have to travel further than 75 characters before wrapping.
Okay, so we've mechanically locked in the shape of our text block. The vertical space is 1.5 to protect the jumps. The horizontal space is capped at 700 pixels to protect the distance. We have a perfectly contained, perfectly spaced box of text.
We do.
But if a user opens a dashboard and just needs to find one specific data point, a uniform box of text is useless. How do we guide their eye to what matters inside that box?
That requires moving from the shape of the text block to the visual hierarchy within it. And the primary mechanical tool for establishing that is font weight.
Okay.
Font weight dictates the physical thickness of the letter forms. In CSS, it's defined on a numerical scale, starting at 100, which is a microscopic hairline thickness, and it scales up by hundreds, all the way to 900, which is an intensely heavy, massive black weight.
Now, if CSS gives me 9 different stops on a scale, my instinct as an engineer is to utilize the entire scale to build a highly granular system, like maybe 900 for the main title, 700 for subtitles, 500 for introductions, 400 for body text, 300 for captions, and 200 for fine print.
And if you do that, you will completely destroy the visual hierarchy of your interface.
Really? Just by using the tools provided?
Using 5 or 6 different font weights on a single screen creates total visual chaos. The human eye cannot easily distinguish the structural difference between a 300-weight caption and a 400-weight paragraph when they're sitting right next to each other. It just looks like a mistake.
It's noise. It's just too many variables for the eye to parse.
Precisely. The core rule from the source material for professional UI development is to use font weight strictly for structural hierarchy, not for decoration. And to do that effectively, you must limit yourself to a 2 to 3 weight rule.
Only 2 or 3 weights for an entire application. That feels incredibly restrictive.
It is.
But wait, actually, if I map this to back-end infrastructure, it makes perfect sense. Think about server log levels.
Okay, like this.
We don't have 9 different severity levels for logs. We essentially use 3, ANFO, warn, and error.
Let's follow that logic. How would those map to a UI?
Well, your info logs are the baseline. That's the bulk of the data flowing through the system. In UI terms, that's your standard body text. So your 400-weight regular font is your IFO level. It's just there to be consumed.
Okay.
Then you have warn logs, something that requires a bit of attention, maybe an edge case or a secondary label, but it isn't breaking the system. That would be a 500-weight or maybe a 600-weight medium font, used sparingly for form labels or secondary emphasis.
And your error logs.
Error logs are critical. They must be seen immediately to understand the state of the system. Those are the page headings. The 700-weight bold text. It stops the user's eye completely.
That is a brilliant translation. If you configure your server to flag every single minor database query as a fatal error, the resulting alert storm renders the entire logging system useless.
Right, the noise drowns out the signal.
The exact same thing happens in an interface. Using 5 different weights is the equivalent of making everything a fatal error. If everything is bolded, or if you use 6 different weights competing for attention, the user cannot easily scan the page to find the critical anchors.
Makes total sense.
You really only need regular 400 for your INFO text and bold 700 for your error headings. That contrast alone creates perfect clarity.
Okay, what about the opposite direction, though? If 700 is an error, how do I handle something I actively want to de-emphasize? Like a timestamp or legal fine print. If the body is 400, my instinct is to drop the fine print down to a 200 or 100 weight so it fades into the background.
Dropping to a thin font weight for fine print is actually one of the most common mistakes in UI engineering.
Really?
Yeah. Thin fonts, like 100 or 200 weight, require extremely high-resolution displays to render clearly. On standard monitors, the delicate letter forms snap awkwardly to the pixel grid. They look jagged, and they quickly become completely illegible, especially at small sizes.
So how do you push information to the background if you can't thin it out?
Here's a pro tip for de-emphasized text. You leave the font weight locked at your standard 400 INFO level, but you modulate the color.
Oh.
Yeah, you change the text color from a stark black to a mid-gray, or you reduce the opacity of the text layer. By lowering the contrast against the background, you successfully reduce its visual priority without sacrificing the structural integrity of the letter forms. The text remains mechanically legible, it just sits quieter on the page.
Modulating the color rather than the weight. That is a very elegant programmatic solution. You keep the variables constrained. All right, so we've tuned the vertical line height, the horizontal maximum width, and we've locked in our log level font weights. That brings us to the final mechanical dial for text. the horizontal space between the individual characters.
Right. And the transition here is really a warning. This is the dial you usually shouldn't touch. In typography, this concept is divided into two distinct ideas: kerning and tracking.
Okay.
Kerning is the specific spatial relationship between two individual letters, like tucking a lowercase o underneath the overhang of an uppercase T. Tracking, which CSS controls via the letter spacing property, is the uniform horizontal spacing applied across an entire block of text.
Before we go deeper, CSS usually measures letter spacing in a unit called an. What actually is an? I see it everywhere in front-end code, but I've never fully grasped the math.
It's a relative unit, historically derived from the physical width of the uppercase letter M in a given typeface. But in modern CSS, 1M is simply equal to the current font size. If your font size is 16 pixels, 1M is 16 pixels. If you set your letter spacing to 0.1 mm, you are adding 1.6 pixels of space between every single character.
Got it. So we are tweaking the microspaces between characters, but earlier you mentioned that professional font designers spend thousands of hours optimizing these fonts. They've already calculated the exact negative space required for an A and a V to sit next to each other perfectly.
They absolutely have.
So what does this all mean? If they've already done the math, why did CSS even invent the letter spacing property? Why are we ever tweaking letter spacing in CSS? What's the edge case?
This raises an important question. For standard body text, you shouldn't tweak it. You should absolutely leave it alone. Overriding the default tracking on a paragraph of body text almost always degrades legibility. The letters start to disconnect from one another, and word recognition plummets. However, CSS exposes the property because there are severe edge cases related to scale and casing, where the designer's default math breaks down. The primary exception is uppercase headings.
Why does uppercase break the default spacing?
Because a typeface is inherently optimized for sentence case. It is designed for lowercase letters with varied shapes, some tall, some short, some round to interlock naturally and form distinctive word shapes.
Ooh.
When you force text to be entirely uppercase, you strip away that variation. Every letter becomes a dense, solid rectangle.
Oh, I see. A block of uppercase letters is just a wall of solid vertical lines.
Exactly. When you have a large H1 heading that is all uppercase, those dense rectangular letters sit physically closer to one another at their peaks and baselines. Visually, the word becomes claustrophobic. The letters bleed into one another.
So they need air.
Yes. In that specific scenario, the mechanical fix is to apply a very subtle positive tracking value, maybe letter spacing, 0.05 e-meter.
Just a fraction of a pixel.
Just enough horizontal air to force those dense uppercase blocks apart, allowing the eye to quickly identify the individual characters.
Is there ever a scenario where you would use negative tracking, where you actively pull the letters closer together than the default?
Yes, on massive display text. If you have a hero banner on a website where the font is scaled up to, say, 120 pixels wide, the default tracking often suddenly looks far too loose. The physical gaps between the letters become gaping holes at that massive scale.
Oh, because the space scales up proportionally with the font size.
Right. Applying a tiny negative tracking value like minus 0.02 am pulls those giant letters slightly closer together, ensuring they still read as a single, cohesive visual unit rather than scattered individual letters.
But again, these are extreme edge cases, giant hero text or claustrophobic uppercase strings. For our 400-weight INFO logs, our standard body paragraphs, we leave the letter spacing completely alone.
Trust the font designer for the body text. Step in to manage the extremes. That's the rule.
It's fascinating how much of this boils down to pure engineering constraints. Mastering UI text isn't about applying artistic flair or having an eye for beauty. It is about actively configuring the CSS with strict mechanical parameters to protect the parsing capabilities of the human eye.
It really is systemic.
You enforce a 1.5 line height to protect the return sweep. You enforce a 75-character linter limit via max width. You restrict yourself to strict log-level font weights to establish a predictable hierarchy, and you leave letter spacing alone unless you are debugging a specific uppercase issue.
When you apply these constraints, the UI instantly stops fighting the user.
We've locked down the core mechanics today, but the journey of rendering perfect text doesn't stop here. Moving forward, in Chapter 6, we'll be exploring how you take these perfectly tuned blocks of text and start pairing different typefaces together without causing a visual collision.
That's where it gets really fun.
We'll also dig into common typography mistakes and how typography subconsciously communicates emotion and brand personality before the user even reads a single word.
There is a deep psychological layer to typography that we've barely touched.
Thanks for joining us on this deep dive.